Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Campus. Subject that I teach in this seventh semester is Optoelectronics and Optical Communication. The topic that we discuss today is fiber material and fabrication. You know, we start with the materials that are used for manufacture of optical fiber. So before manufacturing, the material that we require should meet certain level. The material that we choose is such that when we make fiber from that material, the fiber that made should be flexible and long, thin. So the material that we choose in manufacturing of optical fiber has certain properties. These properties such a way that when we made an optical fiber from that material, the fiber should be long, thin, flexible. So this is the first requirement. Second point is material must be transparent at a particular optical wavelength in order to fiber to guide light efficiently. Third point is physically compatible material that have slightly different refractive indices for core and clouding must be available. Third, as you know, then optical fiber, there are three regions: core region, cladding region, and outer protection. But the two important region is core and cladding. Core is the middle region, and cladding is the middle region. And we also know that the refractive index of core and cladding are different. So the material that we choose, you know, to manufacture a core is different, and the material that we choose for cladding is different because what we want actually we want that there is a slightly different you know refractive index of core and cladding, and this is a requirement of optical fiber. The core having refractive index is slightly more as compared to the refractive index of cladding. So basically three types of fibers are available: glass fiber, plastic fiber, and photonic crystal fiber. These are the types of fibers that are available in the market. Now, uh, method of manufacture of these fibers. So, optical glass fibers. Most of the fibers are based on glass. So we have an optical glass fiber, and the method that we have in liquid phase, the melting method, or chemically vapor phase oxidation. Liquid phase method. In this particular method, we we have we should have a molten glass. The glass should have a molten state. After that, you can take this molten glass and uh, you know any shape that you want can be possible, and it is only possible when you have a glass in molten state. So we have to draw the fiber from the molten glass, means we manufacture the fiber from the glass which is in molten state, right? And which are placed in two concentric crucibles. That's why we call it as a double crucible snap, right? And draw a glass from a glass rod called perform. Actually, there is a glass rod, that we glass rod, and of course in a molten state, and take uh, we take the that glass uh, from this glass rod, which we call as a perform. So then fabrication of the perform, drawing the fiber from the perform, coating, jacketing, and labeling process. So these are the process involved in this method. First of all, draw the fiber from the molten glass, right? Molten glass that we called as a perform. then fabrication of the perform, drawing the fiber from the perform, and coating, jacketing, and labeling process. This means this is for outer protection. Liquid phase method. These are the pics of this particular method, which is called as the liquid phase method. So in liquid phase method, try to understand that perform is fed into perform is it's a rod of molten glass. Perform is fed into circular heater called drawing furnace. Right? Second, perform end is softened to the point where it can be drawn into a very thin filament. Which fiber. Obviously, and second point is very obvious. Then the perform end should be softened so that we can take this little bit of glass from that perform and force into some very wire type of shape that we call as optical fiber. Then there is a drum also. The speed of the drum at the bottom of the draw tower determines how fast and in turn how thick the fiber is. And the last point is an elastic coating is applied to protect the fire. So this elastic coating is required to protect core as well as cladding region of the fabric. And this is the figure of this particular liquid phase method. So first of all, we have a drawing furnace that have this molten rod that we call as a perform, and then there is a thickness monitor. We also monitor the thickness because thickness of the optical fiber is very less. And, time we call as in, maybe so. This is the concern. The concern is the thickness. The fiber have a very less thickness. Then after that, then we have a coating. Coating is required. In last, when we have a optical fiber ready, then we perform, a coating method. Silica and halide glass fibers can all be made using a direct melt double crucible techniques. Glass rods from the core and cladding material are first made separately by melting mixtures of purified powders. These rods are then used as feedback for each of the two concentric crucibles. Advantage of this method is being a continuous process. Careful attention must be paid to avoid contaminants during manufacturing. Thanks. Actually, this particular topic is very much theoretical. Nothing to be, very conceptual. No concept. Just read, go through the book, take these particular topics, and just read the topics, and also the diagrams also. So this particular section is a theoretical, so no concept involved in that particular